Okay, hey everyone, welcome to the final subtopic for neuromuscular function and fatigue. Today's focus, as you can see on the slide, is fatigue. Now, I know fatigue is something we've all felt, whether in the middle of a tough workout or just trying to get through the week. But in exercise physiology, fatigue has a very specific meaning and some really interesting mechanisms behind it. Okay, so let's break it down together. Nothing too technical, just real practical understanding. Okay, so let's get started. Okay, so let's start with the basic question. What is fatigue? Okay, let's define what we mean by fatigue. And no, it's not just being tired. Okay, if you look here on the slide, okay, fatigue is when your muscle basically can't generate the same force or power it normally does, especially after prolonged or intense activity. This is when you feel like your body is slowing down or your strength is just not there. Now, it's important to note that fatigue comes in two flavors. Okay, central, which has to do with your brain and nervous system, and peripheral, which is more about your actual muscles. Right, and here's a few things to remember here. Okay, fatigue is reversible, right? So it's not permanent damage, right? It's not the same as injury or muscle damage, and it's influenced by a bunch of things like how intense or long the activity is, the environment you in, and how fit you are. So fatigue is more than just I'm tired. It's a complex process we can learn to manage. So if you look at the diagram here, the image here, okay, it speaks about the difference between central and peripheral fatigue. You might pause this slide and read through it. Okay. Now, if you take a look at this table, okay, and feel free to pause if you need to. We've got a side-by-side comparison of central fatigue and peripheral fatigue. But let's keep it simple, okay? Central fatigue is when the issue starts from the brain or spinal cord. So the signal that tells your muscle to contract is weaker or slower. Okay, this can be caused by things like neurotransmitter depletion, okay, especially serotonin and dopamine, or even just mental exhaustion. Okay, peripheral fatigue, on the other hand, happens within the muscle itself. Okay, here we are talking about, it is more about metabolite buildup, like hydrogen ions or phosphate, which can disrupt muscle contraction, and things like calcium not being released properly for muscle contraction. The onset is different too. Central fatigue builds up more gradually. Okay, think of like a very long, mentally tiring sports like marathon. But peripheral fatigue, it hits very fast, like during sprinting or high intensity lifting, such as when you're doing your CrossFit workout, and when you're competing in 400-meter sprint, right? The symptoms also match what you'd expect. Central fatigue, it will cause you to be have a very poor focus, slower reaction time, and so on. When it comes to peripheral fatigue, burning muscles, reduced strength, reduced capacity of moving fast, and so on is what you can expect. Okay, and the way you recover is different too. Mental rest help with central fatigue, while proper physical recovery and rehydration are needed for peripheral fatigue. Alright, so let's just zoom in on central fatigue for a second. You can look at the slide here. We are talking about neurotransmitters like serotonin and dopamine. When their level changes during prolonged effort, it messes with the brain's ability to drive your muscles properly. Okay, so even if your muscles could still go, the brain might say, nah, we're done. Stuff like that. Mental fatigue, stress, and low motivation all contribute too, which is why during long races or games, athletes sometimes hit the wall mentally, even if their bodies still have some fuel in the tank. That's why endurance sports are heavily influenced by central fatigue. The longer the event, the more important the brain becomes in performance. Alright, now on top peripheral fatigue, this is where the muscle itself is the issue. Look at the diagram here, okay? The key causes include, first one is hydrogen ion accumulation, which lowers blood pH. Okay, in simple terms, this is the burn that you feel, on your muscles, right? Inorganic phosphate and ADP buildup, okay, both mess with the muscle's ability to contract, also cause peripheral fatigue. And then there's depletion. We are talking about ATP here, our source of energy. Depletion of depletion of fuel like running low on ATP, glycogen, or creatine phosphate also can contribute to peripheral fatigue. Okay, plus problems with calcium release, which means the muscle just can't contract properly. So the overall effect, a drop in force production. Okay, your muscles working hard, but it just doesn't have the chemistry to keep going at that intensity. Alright, so this one is super practical. Okay, it's about what causes fatigue in actual sports scenarios. Okay, you can check out the table here. It breaks it down nicely. Okay, first we are talking about exercise intensity. Okay, exercise intensity causes fast fatigue. You run out of ATP, lactate builds up, and you'll get muscle acidosis. Think sprinting or HIIT. Okay, and then the next one is the exercise duration. On the other hand, it brings low fatigue. Okay, it causes glycogen runs low, the brain gets tired, dehydration kicks in, such as in marathon, right? The other factor is the environment. Okay, the environment plays a big role too. Okay, heat increases core temperature, as we all know, reduces plasma volume, and adds cardiovascular strain. Think of playing football under a hot sun, right? And then hydration and nutrition are major players as well. If you don't feel or hydrate properly, your performance is gonna drop, no matter your fitness level. Okay, and don't forget about mental fatigue. Poor sleep, stress, or even lots of decision making during a game can reduce your motor, drive, and focus. Okay, so it's not just one thing. Yeah, it's usually a combo that leads to the fatigue state. Now that we know the types and causes of fatigue, how do we track it and deal with it? First, let's talk about monitoring. The classic one is RPE, which is the rate of perceived excretion. Just asking a simple question like how hard was that, or from a scale from 1 to 10, how hard was the exercise? It might give you a real insight. Okay, and then we have all of these lab-based result, EMG changes, force output decline, and biochemical markers like lactate or creatine kinase. They are quite expensive to operate, but they will tell us a lot, especially in tracking fatigue and eventually overtraining. Okay, and as for management, it's all about recovery and planning. Okay, first one, smart training periodization helps avoid overtraining. Okay, we are talking about the balance between training and rest here. Okay, getting enough sleep and rest days is crucial because recovery only happen after you have enough rest. First rest, then recovery, right? Nutrition also plays a big role. Okay, carbs for fuel, hydration to maintain blood volume, and even caffeine for boosting alertness. And yes, psychological strategies help too. Okay, we are talking about mental skills training or motivation techniques, right? So don't just train harder, you have to train smarter. Alright, so let's just wrap this topic up with some key points, and you can refer to the slide here to follow along. Okay, the first one is fatigue is multifactorial. Okay, it's not just muscle or just your brain. Most of the time it's a combo. Okay, different sports will trigger different types of fatigue, so your training and recovery should match your sport. Okay, next one is understanding fatigue helps with training design, injury prevention, and improving performance. And lastly, coaches and athletes can use this knowledge to better manage the phase of tapering off, recovery, and overall workload. right? So the bottom line is fatigue isn't just something you push through, you know, it's something you can manage if you can understand it. And that's it for this topic. Thanks so much for going through this subtopic with me. Okay, fatigue might sound like a simple thing, but there's a lot of things going on behind the scene. You know, the more we understand it, the better we can train, recover, and perform. So that's all for this chapter. Okay, I'll see you on the next one. Thank you.